Leetcode 198, house robber. It's a medium problem and it's quite standard for medium. And in the same time, it's an entry level when it comes to dynamic programming. So here is the description. You are a professional robber planning to rob houses along a street. So our task is to rob houses along a street, so we have to rob as much as possible. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Yes, of course, we want to rob as much as possible, but if we could rob each house, then this wouldn't be any interesting problem. And the constraint is that we have to skip certain houses. Yeah, we can skip multiple houses, but we cannot rob adjacent houses. So we cannot just rob one next to each other. And given an integer array nums, so here they describe the input. Usually input is described first. Here they describe it by the end, represents the amount of money of each house. Return the maximum amount of money you can rob tonight without alerting the police. So let's take a look. We have the single input called nums, and here we have following amount of money, like money amounting to 1, 2, 3, and 1. Yeah, the output is 4 because we can rob house number 1, take 1 money, and then rob house number 3, and take 3 money. And the total amount is 1 plus 3 equals to 4. And in the second example, we can rob house 1, take 2, then house 3. Yeah, so we skipped house 2. No, sorry, we only skip one house. Yeah, so first 1, then 3, and then house 5. Yeah, so each time here we just took every second house, but of course it could be there could be other options as well when we skip more than a single house at a single in a single iteration of this robbing. And let's now copy this house robber and copy also our example. And let's think about a way in which can we use this dynamic programming approach. And of course, dynamic programming is like a loose connection or loose collection of different approaches and strategies. Wherever we have somewhat hard problem that can be subdivided to sub-problems. Yeah, and usually we either use a recursive approach or iterative approach. In this case, we'll use iterative approach, which is called tabulation. Yeah, and we try to first compute those smaller sub-problems and go one by one until we reach the bigger problem. And let's just write it down, how the strategy is called tabulation. And of course, there will be like overlap between the sub-problems. That's why we call it dynamic programming, and that's why we are caching the results in a table, yeah, or in an array called usually DP. Yeah, so that's our store here where we that's our table where we store the results of sub problems. In this case, how much can we rob till given index? Yeah, so on index 0, it will be how much can we rob till the 0th house, which doesn't exist, but we start with this base case. And then on index 1 would be how much can we potentially rob till the first house, second house, and so on. And of course, each of this will depend on the previous steps. And we can always take either, we can either get the money that we robbed from the previous house or the house before the previous house plus the current. Yeah. So there are two options. Let's maybe first write the base case. And the base case, of course, is that dp of 0 is equal to 0. And then there is standard case or normal case, where we have two options: either eat the house or rob it. And then on each eye will be maximum between what we have gathered in the previous house, if we decide to skip it, or we decide to rob it, meaning that we get the new number or the new amount from our input, plus what we have gathered so far, but not on the previous, because we cannot take two adjacent homes, what we have gathered on the index I minus 2. That's it. So there are the only two cases that we have. That's why it's like an entry level DP. And of course, it could be much harder, but here we have either skipping or robbing, and this is robbing. And now let's think about, in this case, that example. And I paste it. No, it tries to paste as chart. So let me write it down again. 2, 3, and 1. And let's try to visualize how does DP change. For various i's. First, let's start with I equal to 0, and we will have the following state: 0 and either infinity or like empty for the 4 cases. Then in the next iteration, we can rob the first house. And of course, always makes sense between this and this on the first step to rob the first house. So it's the maximum, so we choose that option. And then we can, the second, we can also choose to rob. And then on the fourth iteration, and when we have 3, we can choose between skipping or taking the one before the previous one, and this is the best option that we have. It's 5. And the last one, I equals to 5. Here we have, we can either skip, and this would be the best thing to do, to skip in this case. Okay, so now let's try to create our table here in Python with n elements, and the first house we always take, and then for the second, it's also special case, we will take the maximum between the first 2 houses. And in our case, the maximum was on the second house, and then we can do the loop for I in range n to 2 to n, and let's also create n, by the way. The length of numbers we can do the following. And that's why we had to create to fill those two already. And by the way, yes, 0 is already filled, then the first and the third. Yeah, should work, because otherwise we would get index out of range error here, or we could put like an if statement inside the loop, but this wouldn't be that nice. So I think this is a better approach, and then we can return the last element of our DP. If n is equal to 0, then we return 0, and if n is equal to 1, then we return the first house, since we cannot rob any more houses. And I think that's all the edge cases that we have here. Let's try to run. And we have num as nums on index I in our case. Wrong answer. 4, let me take a look. In this case, we would have to, we could keep it like this, but then we would have to extend the n plus 1 and here as well. But it's better to probably move it here, one index less, and keep it the way it is here. And that's it. Yeah, so we could keep those indices 1 and 2, but then would have to go here to n plus 1 and do I plus 1 everywhere. Yeah, so I think that's the easier option out of those two. Simply put the first number, the first amount of money in the first cell. And by the way, what did we do here? Yeah, here we added this additional 0, but it's not needed. Yeah, so we could basically remove this part, but everything else stays the same. And now the time complexity is O(n), because we have just a single loop. Yeah, so it's a linear time complexity. And the space complexity is also O(n), because DP, this additional space that we are using, is dependent on n and is simply using n elements inside. Yeah, so both O(n) space and time complexities.